Okay, so moving ahead, to another most interesting topic, introduction to graph data science. Sharmin, do you know who's going to deliver this session?
Yes, Vaishnavi. He has done PhD in geometric modeling algorithms and also he is Google developer expert in machine learning.
Along with this, he is a true expert in the field of data science, artificial intelligence, machine deep learning, NLP, and last but not the least, generative AI. Without further ado, please join me in welcoming the brilliant and knowledgeable Dr. Yogesh Kulkarni.
This topic is rather different than what you have heard so far. It's not very related to Google Cloud, but related to Google Cloud. How many of you have done machine learning? Please raise hand. Okay. So this talk will make sense to them. Rest can go back to their mobiles. All right. So there are two places where we use term called graphs. Okay. And we are talking about one of them. So if you have done 12th standard, I hope everybody, you must have got the graph paper and then P versus V and a Boyle's law and drawn a straight line. That graph is not what we are talking about. This is called chart. Okay. What we are going to talk about is what is called as data structure graph. If you have done data structures and algorithms, arrays, lists, next chapter is stack, queue, tree, and the next chapter is graph. That's what we are going to talk about. Okay? It's basically a tree with a loop back. Well, loops are allowed. Okay? That's the graph we are going to talk about. As we can see, everything is connected. So, graph is everywhere. Okay? Network of people. We have friend circles. Friends have friends. Those friends are our friends also. Meaning, there is a loop. So that is what is called as network or graph in this sense. So network of people, transactions. You paid to somebody, that paid to somebody, and that paid to me also, right? Again, some loop. Giving some sense of graph or network and knowledge network. So basically, wherever you see connectedness amongst each and things can come back to you. That structure, vaguely you can call it as a graph, right? And we are going to talk about graph. By the way, as most of you have done machine learning, at certain places during this presentation, we'll see the difference between this and machine learning. That's the key takeaway you should take home. This is a vast topic. We cannot cover it in 20 minutes, 15 left. Okay. Basically, if you have done machine learning, you must have done Titanic, right? Titanic data set, everybody, right? No? Yes. So basically, what is Titanic? We have a list of peoples in rows, and whether that guy survived or not, right? That's it. But all these rows, all these people are unconnected. Meaning, while doing machine learning, we don't take use of the relationship among them. By the way, some of them were families also, right? Some are siblings, some are spouse or whatever. But that information we are not using in machine learning. That's what graph data science is all about. And we'll see that slowly, rather quickly. Okay. Data science, science of data. If there is no data, there is no data science, right? That's just a sales pitch, right? If there is no data. So basically, if you are using data to do something, descriptive, predictive, and prescriptive, then you are doing data science. What is graph data science? Very simple. When data is graph, that's graph data science, isn't it? A data science done on graph as a data is graph data science. And graph is what we saw, the networks. The connectedness is what graph is. And basically that's the key, data scientists who use relationship for doing data science. That's where graph data science comes in the picture. This is most important slide. If you don't take anything from this presentation, take this slide. So again, if you have done Titanic, what it has number of people, and number of columns, isn't it? That's the X part of doing prediction. Everybody, right? That's the X matrix. Everybody has same number of columns, meaning it's a fixed size row, isn't it? And no two rows are shown to be related. Naturally they are internally by family ties or whatever. So that's the classical machine learning that we have been doing so far. So we are ignoring relationship amongst rows. And the data is fixed. Both things are not there in graph data science. Things are connected. Things are related. One row is connected to another, or node is connected to another. And the graph sizes are different. Assume almost like one row is 3 columns, another row is 5 columns, another row is 7 columns. That's how this problem is difficult, challenging. Got the sense? It is different from normal machine learning that you have been doing so far. The topology, the connectedness is different for every case. And then, of course, in graphs, we have to use relationship as well as variable sizeness. Graphs are there in all stages of machine learning. Oh, okay. Knowledge graphs, analytics, normal analytics, and machine learning. Just 8 minutes left. I'll quickly move forward. Many applications, you just quickly have a glance at it. We'll touch upon one or two little later. Okay, that's about it. I've divided further part in three parts. Knowledge graphs is how data is represented as graph. We'll see a few examples. So this is static data, just data. Next, we'll talk about what kind of algorithms are available on data. Graphs. Graph is a data. And third thing, can we do machine learning on graphs? So 3 stages. First is data as graph, algorithms on graphs, machine learning on graphs. We'll quickly move. What is knowledge graph? Simple. Everybody, this is almost like what we have in social networks. One person is connected or related to another person, and the connection type may be anything. Married person or a sibling, and it need not be all nodes meaning connection points, to be of same type. There could be a network of 2 people connected, but these 2 people can like car. So it is a heterogeneous node kind of network also. So knowledge graph has different types of nodes, different types of relationships. What it is doing, it is capturing the knowledge. It is capturing the relationship. And of course, this is very useful to answer certain queries. Why are we doing all this? To answer certain queries. And we'll see one example later. Okay? Knowledge graph is dumping your knowledge in a graph format. Isn't it? That's what it is. By the way, apart from GD, I'm a Neo4j ninja also, meaning Neo4j is graph database, and this is SQL-like query language for graphs. It's called Cypher. Some code snippet for Cypher. So it is trying to see if knowledge graph is there. It is trying to match a pattern. One node knows another node. How many such pairs are there? How many such relationships are there? It is trying to bring in. This is a little different than SQL that you have done so far, right? So this is a little different. That's why language is, although it looks little like SQL, but not SQL. And of course, visualization. So we are still seeing graph as a data. What can we use it for? In financial domain, of course, we can find out who are related, who is transferring money to who is transferring money to whom, and is that money coming back to me? Can you sense some fishiness here? These are the transactions people do, and this is used to do fraud detection. So that's how simple graph, no machine learning, nothing, just a query that this cycle has formed. That itself gives you an insight. And many such things. Section 2, 5 minutes left. Okay. Normal algorithms, not machine learning. Simple algorithms, we'll touch upon a couple of them. A very known one, path finding. If you're driving from here to Aurangabad to Nagpur, or whatever, two cities, which is the shortest path. Shortest path not just by distance, but maybe any other attribute like traffic. Whichever has least traffic, although it may be a longer one, you still prefer to go by a shortest. So it is a distance or a time that is the measure. So path finding, centrality. Any example that you can think of? Our social network, we are connected to these guys are connected to these guys. That's the social network. What is centrality? Centrality is a person, meaning a node, say who is connected to most number of people. So a lot of people are connected to that guy. That guy is an influencer, isn't it? Why this is important? Because if I pay him to propagate a message, that's most effective than an isolated guy who is not connected to anybody, isn't it? That's how it can be used. Influencer, many things. Community detection is a clustering algorithm. So these are basically simple algorithm, not simple, simple use cases that we can think of on graphs. Many algorithms. I'll just wait here for a second so that you can gauge what kind of graph algorithms are popular. By the way, graph as a technology is probably 500 years old. And if you haven't heard of a guy called Euler, you should go back and do that. He's the first guy who said what is called as traveling salesman problem. If you're interested, go back and search about it. Basically, that's the graph algorithm for traveling salesman problem. Anyway, multiple algorithms. 3 minutes. Last is machine learning. Okay. So far we saw graph as a data, graph with algorithms. Now, can we apply machine learning on graphs? What is machine learning? It is not description of the data. It is prediction using data. Right? We are thinking of doing something else. So what can we predict? Given a graph, can we predict properties of certain nodes which are not labeled? Right? That is one use case. Can we find edge? Predict an edge between two nodes, which is currently not there. What is the use? If I'm connected to Sayak is connected to this, I'm connected to this guy. Can I predict that this link may be useful? So this is nothing but friendship recommendation, isn't it? Currently there is no linkage, but I'm predicting it. I'm getting it as a recommendation. So that is machine learning, that is edge prediction. And one more prediction possible, totally as a graph. If you have done some chemistry in 12th, these molecules almost look like a graph, right? This atom is connected to this by this kind of bond. So that's a molecule. Is this molecule useful or not useful? Simple prediction. If we are doing this kind of prediction, the whole molecule, meaning the whole graph, becomes your input. And it can be of variable size. So can we do that kind of prediction? That is very useful in drug discovery or in life sciences. So we saw, 1 minute left, knowledge as data, algorithms on graphs, and machine learning on graphs. I'll quickly shift now. Why graph data science is in GCC, Google Cloud Community Day? Because Neo4j graph database is available on GCP. Okay, so you can use all the functionality that is there in Neo4j while being on Google Cloud. That's why this talk was allowed here. All right. So they have a library called GDS, Graph Data Science Library, in Neo4j, which of course some syntax, how you can call graph data science algorithms. This is how it looks. Okay. Where do I find? Neo4j.com. Okay. If at all you are interested in graph data sciences on Neo4j, this is the one. Quite a few things are available. Maybe I'll just give you a few more things. Yeah. They have a Graph Academy. By the way, graph, as you might have guessed by now, is a very difficult topic. But that's the next upgrade in my opinion, apart from the classical machine learning that you have been doing. So if at all you are interested, Graph Academy is the source. They have 2 certifications which are free. These are the ones. I happen to do the first one. I'll wait here for a second. 30 seconds more? All right. All right. There's a conference coming up. I wish that whoever is interested can join this conference. And if at all you are ready to give a talk on graph data science, please submit your talk there. That's about it. This presentation is highly borrowed from many sources. These are the sources. That's about it. Thank you. If at all you are... Oh, okay. I'll take up questions offline so that we can start with the next session. If at all, in the meantime, interested in connecting with me, sort of self-marketing pitch. This is my LinkedIn and Medium. Don't send connection requests, they are full. You can just follow me, okay? Thank you.
Thank you, Yogesh sir, for introducing us to this mesmerizing topic and the world of graph data science.
Okay, now for felicitating Yogesh sir, I would like to call Mr. Amay Nerkar to the stage.